Nowadays, computers are used everywhere, from servers and mainframes residing in organizations' data centers to desktops, laptops, tablets, smartphones, and even video game consoles, computing devices embedded in cars, appliances, etc. While differing in size, functionality, and cost, all computing devices are programmed to carry out a set of instructions, also known as programs or computer code. To get a basic understanding of how a computer works, let's look at an analogy to a totally different aspect of our daily lives: cooking. Think about computing as cooking and the computer as the cook. When we cook, we need the ingredients to make the food, and we need well-defined cooking procedures such as a recipe. We also need a working space like a counter, cooking tools and utensils that are readily accessible and which we know how to use, and we need storage for everything: a place to store the ingredients, the finished goods, the utensils, cookbooks, etc. So in a nutshell, cooking is a process in which a cook takes ingredients as input, processes them based on instructions from a recipe, and sends the output result as a dish. Similarly, you can view computing as the process in which a computer takes data as input, processes it based on instructions from a program, and sends the output results to the user. For example, when you touch your smartphone, click the mouse on your laptop, or even punch a key on an ATM machine, something is happening in the background, and within a very short time, you get a result which can be a display of a web page, say a display of the last transaction in your bank account, or in the case of the ATM, you can get cash. Let's try to get a better idea of what is happening in the background, from the moment you touch a key or click a mouse until you get the result. To do so, let's take a look inside the computer. Inside the box, you can find a power supply, some drives like a CD or DVD, and other components and wires. But the heart of the computer is a board attached to the back where all the needed equipment and components are either built into this board or attached to it. This is what is called a motherboard. In general, we can take a look at 5 categories of hardware. We'll start with processing, then look at input and output, connecting devices, storage, and communication. The central processing unit, the CPU, is where the actual computation work is done. It is made of millions of small electrical gates called transistors, which are printed on a silicon chip. Some CPUs are designed to perform a specific task, like controlling a heating unit, while others are designed for general-purpose computing. You can think about memory as the counter space in the kitchen. It is like a digital placeholder, a place for the CPU to take data from and stage it during and after processing. Think about memory as a piece of paper used by the CPU. If you are multiplying two large numbers, say 3 or 4 digits each, a paper and pencil can help you. You write the numbers that you want to multiply, you write the carryover and the products you need to add in order to get the final answer. In other words, memory is a temporary holding area for data and programs that are used by the CPU. How is the data transferred from the CPU to memory and back to the CPU or to other devices? Let's look at 2 ways to transfer the data: a dedicated connection and a shared connection. To better understand the differences between the 2 methods, consider a hypothetical world in which each employee has a private road paved from his or her house directly to the office building where they work. Wouldn't it be wonderful, your own private road that you do not have to share with other drivers, no stop signs, no traffic lights or cars that you need to pass? As much as it sounds great for our busy lifestyles, it is obviously impractical. It is very expensive to build and maintain, and even more expensive to modify. Can you imagine the cost of relocating to a new office or working for another organization? It can take a long time to get from home to work, but by sharing the roads, we created an affordable and expandable infrastructure, as new homes can connect with new roads to the existing infrastructure. Consider another shared resource that we use: public transportation, which enables people to get from point A to point B. Anyone in town can use public transportation and ride the bus. And because bus stops are predefined, you know where to get on and where to get off. That's exactly how all the devices inside the computer are connected. Each device has an address. The bus connects the CPU with all other devices. Data, including the address of the device and control information that tells the device what to do with the data, is transmitted on the bus from device A to device B in the form of a stream of electrical signals. These data flows between the CPU, memory, and other devices are synchronized by a clock that ensures that connection between the CPU and each device is done during dedicated time slots. The second category of hardware is input and output devices. These are devices that connect the computer and the electronic heart of the computer to the real world around it. Humans use their five senses to see pictures, hear sound, smell, sense heat, and so forth. Inside the computer, however, it is all electronic, which can be represented by streams of zeros and ones. We need a way to convert from the real-life data into the computer. In order to do it, we use input devices, which in essence are sensors. We use a camera to capture pictures, microphones for sound, we can measure temperatures, we have sensors for touch, and so on. Whatever sensor we have, it converts the data to an electrical signal that is digitized and then sent to the computer. Inside the computer, this data can be stored, processed, or sent to other places. The other direction, from the computer back to the real world, is done by output devices. We take information from the computer that is digital and attach a monitor that can display an image or speakers for sound, and then send the information that is stored or was processed on the computer back to the real world. In some computers, the integration of input and output devices is seamless. For example, in a smartphone, the touchscreen provides both input and output functionality. A closer look reveals that there is an LCD display in the background and a touch-sensitive screen or pad in the front. By placing a translucent touchpad on the top of the LCD and having software that synchronizes what you see in the background together with the sense of the touch in the front, you can get an input device and an output device that look and behave like one. The third category of hardware devices are the connecting devices. We need an option to connect external devices to a computer. The connector can be an extension board. The one you see in the picture is for video. The connector can be a port like a USB. There are different kinds of cables and so forth. So everything that lets you connect devices to the computer is falling under the category of connecting devices. The fourth category of hardware is storage. It helps us save documents, programs, music, movies, and so on. Whether the storage device is a hard drive, a tape, CD, DVD, a flash card, and so forth, they all provide the same functionality, saving data that can be taken from the computing device and be used at a different time or a different place. Last but not least, we should mention communication devices. As opposed to connecting devices that connect the CPU with other devices such as an external disk, a microphone, or a headset, communication devices enable the computer to exchange information with other computers over communication lines such as the Internet. In this case, there is no need to attach to an analog device or sensor, since both computers send and receive digital information. Nowadays, the distinction between the hardware categories can be somewhat fuzzy, like when we talk about storage and memory as two different functions. For example, a solid-state disk is a unit that provides both a memory and a storage device in a system. This technology is available today on some computers and on some smartphones. To summarize, the heart of the computer is the CPU and the memory. They are connected via a bus, which also enables transfer to and from other devices. Input devices bring information from the real world, convert it into an electrical signal, digitize it to zeros and ones, so that the computer can use it. Output devices work in the other direction. They take information from the computer and change it to sound, picture, or other kind of forms that humans can sense. Connecting devices and ports like USB let us connect different devices as input or output. Storage devices help us store information from the present so that it can be used in the future and/or another computer. And communication devices enable the exchange of data between computers. In the same way that one can drive a car without necessarily understanding how the car works, one can use and operate a computer without understanding the ins and outs of the computer. But as with cars, it is a good idea to have a basic idea of what is going under the hood.